Hey guys, Miss Pratt here. Just going to talk really quickly about some special right triangles that help us derive some exact trig values. So for this lesson, you're going to want a calculator that can do sine, cosine, and tangent in degree form. So the first thing I want you guys to understand is that some trig values can be integers. Like for instance, I can find sine of 90 degrees, sine of 0 degrees, and tangent of 45 degrees on my calculator, and I will find whole numbers. Sine of 90 is 1, sine of 0 is 0, and tangent of 45 degrees is 1. There are also some trig values that are rational, meaning they can be expressed as a fraction. For instance, I can find cosine of 60 degrees, and that would be 0.5, which can be written as a fraction 1/2. Where this gets tricky is when we start to talk about trig values that cannot be expressed as a whole number or a rational number. For an example of that would be sine of 45 degrees. If I type sine of 45 degrees into my calculator, I will get 0.707167812, and that's going to keep going. So because of this, I'll never be able to write an exact value for sine of 45 degrees, because at some point I will always have to round this. In math, we don't like to round where we don't have to, and so there is another way that I can write sine of 45 degrees that is an unrounded answer. Sine of 45 degrees can also be written as the square root of 2 divided by 2. If you were to type square root of 2 divided by 2 into your calculator, you would see that it's going to be the same exact number. But this is a irrational number that is not expressed in a decimal, whereas this is an irrational number that is, so we will always have to round it. Whenever we're doing math, if we have exact values, we always want to use those when possible. So this video is going to walk us through how do we find these exact values, where does the square root of 2/2 come from, and how can we use that to then solve problems. Okay, the first special right triangle that we're going to talk about is a 45-45-90 triangle. And so you might remember from a previous math class that this is a right triangle because it's got a 90-degree angle in it. And it's special because when the two angles are congruent, when we have two congruent angles, then we have what's also called an isosceles triangle. If the two angles are congruent, the two sides across for them are also going to be congruent. So we'll have the same measurement for the height of this triangle that we will for the base of this triangle. And so one thing that we can do is we can find the measurements of these sides without using trig at all, but using Pythagorean theorem, as long as we know the hypotenuse. So I'm going to let the hypotenuse be a measurement of 2. Now this measurement is using specifically so that we can derive these exact trig values, but it is important to know that any 45-45-90 triangle is going to be similar. So all the proportions in these triangles should be congruent. So I'm using 2 as the hypotenuse, but you can use any other hypotenuse measurement and you should be able to get the same exact proportions in any triangle. Okay, so I'm going to start by using Pythagorean theorem. We know that a squared plus b squared equals c squared. My a and b are both x, so x squared plus x squared equals my c value squared, so 2 squared, which is 4. And I'm going to combine my x squared so that I have 2x squared. And I'm going to solve for x by dividing by 2 first on both sides and then taking the square root. So I can say that x is the square root of 2. So if I have a triangle, the hypotenuse is 2, then both of the lengths of the legs are going to be the square root of 2. Okay, so now we have all 3 sides in this right triangle, and we have all angles in this right triangle, and so we're going to use this right triangle to derive our trig values. Again, all of these trig values are ratios of sides, And any 45, 45, 90 triangle is going to be similar, so the proportions will be the same. Regardless of what the hypotenuse is, all the proportion values, all the trig ratio values will be equivalent. Okay, so using this special right triangle where we have a hypotenuse of 2 and my legs are the square root of 2, I can define these exact trig values. So I'm going to use 45 degrees, and we're going to use, because it doesn't really matter which one we use as my reference angle, but I'm going to use this one down here in the corner as my reference angle, which would set this as my opposite side, my hypotenuse side, and my adjacent side will be the one next to the angle that is not the hypotenuse. And I'm going to use my ratios. We know that sine is the opposite over the hypotenuse, so that will leave me with the square root of 2 over 2. Cosine is the adjacent over the hypotenuse, which is the square root of 2 over 2. And my tangent is the opposite over adjacent, square root of 2 divided by square root of 2. And the only one that needs to be simplified is this tangent of 45 degrees. If I have the square root of 2 divided by the square root of 2, I can simplify this down to 1. So these are going to be our exact trig values for sine of 45 degrees. We're going to say that it's the square root of 2 over 2. Cosine of 45 degrees is also square root 2 over 2. And the tangent of 45 degrees is 1, which we already said is actually a whole number, and our calculator will spit out that whole number. What the calculator will not tell us is that the sine of 45 degrees can be represented as a square root 2 over 2. It'll give us the decimal format, that 0.0 or the 0.707 number that we were talking about at the beginning of the video. But we're going to want to use these square root 2 over 2's when we can. Okay, another special right triangle is our 30, 60, 90 triangle. And a 30, 60, 90 triangle is actually just half of a equilateral triangle. So I'm going to take this equilateral triangle, I'm going to cut it down the middle, and I'm going to kind of cross out half of it so that I'm only looking at this 30, 60, 90 right triangle. And that's a special right triangle. It does have a right angle measurement of 90 degrees. It has a 30-degree angle and a 60-degree angle, and a couple measurements. So similar to the last measurement, I'm going to set the hypotenuse, or the last right triangle, I'm going to let the hypotenuse be 2. And if you understand in an equilateral triangle that all of the sides are congruent, so if this was 2, and the bottom was 2, when I cut this equilateral triangle in half, the measurement of the bottom, or the one that's across from the 30-degree angle, is going to be half of the total side length. So if I have a hypotenuse of 2, this section down here is going to have a hypotenuse or a leg measurement of 1. And then I'm going to use Pythagorean theorem to actually solve for this side of my triangle. Okay, starting with my Pythagorean theorem of a squared plus b squared equals c squared. The only side that really matters is that I've got my hypotenuse set at 2, and then I'll let a be x squared, I'll let b be 1 squared, and then I'm going to solve for x. So we have x squared plus 1 equals 4. Subtract 1 from both sides, giving me x squared equals 3. And so the value of x here would be the square root of 3. So I'm going to record that. And again, this is these measurements are specifically true for the 30, 60, 90 triangle, where we have 2 as the hypotenuse. But again, since we're looking at the ratios of the sides, we're looking at the trig values, sine, cosine, and tangent, any 30, 60, 90 is going to be proportional to this triangle. So these ratios will be the same regardless of the shape of the triangle. We're still going to preserve these ratios. Okay, so we're going to use this 30, 60, 90 triangle with a hypotenuse of 2 and legs of measurements 1 and square root of 3 to find 6 exact trig values. So first we're going to start with 30 degrees, and so I'm going to set my triangle up so that my reference angle is my 30-degree angle. If my reference angle is my 30 degrees, my hypotenuse will still be 2. The side across, or the opposite side from my 30 degrees, is the measurement 1. The side adjacent to my 30 degrees is square root of 3. Okay, so to find the sine value of 30 degrees, I'm going to use opposite over hypotenuse. The opposite value is 1. The hypotenuse value is 2. So sine of 30 degrees is 1/2. Cosine of 30 degrees is adjacent over the hypotenuse. So the adjacent value is the square root of 3 over the hypotenuse value, which is 2. And then my tangent of 30 degrees is opposite 1 over the adjacent, which is square root of 3. Now you might remember from a video that you would have watched earlier that we cannot leave the square root in the denominator. So I'm going to rationalize my denominator by multiplying the denominator by the square root of 3 and the numerator by the square root of 3 so that I don't change the value of the fraction, just the formatting. So when I simplify this, I've got 1 times the square root of 3, which is the square root of 3. I've got the square root of 3 times the square root of 3, which is the square root of 9, or simplifies down to 3. So my final answer for tangent of 30 degrees is the square root of 3 over 3. Okay, I'm going to reset this triangle up and talk about my exact values for 60 degrees. My 60-degree reference angle is down here, and so that's going to change the way I label. My 2 is still my hypotenuse. My opposite side now is my square root of 3, and my adjacent side is 1. See if you can set up sine, cosine, and tangent of this triangle to find the exact values of these functions at 60 degrees. Okay, I have sine of 60 degrees as square root 3 over 2, so opposite over hypotenuse. Cosine of 60 degrees is adjacent over hypotenuse 1/2, and tangent of 60 degrees is opposite over adjacent, so square root of 3 over 1, which simplifies down to the square root of 3. So again, these exact trig values are ways to keep from having to write the decimal form of these trig functions and having to round them. So some of these are irrational, and because they are irrational, if you type them into your calculator, you'll only ever get a decimal that you will have to simplify. So when possible, it is better to use these exact trig values because you don't then have to worry about rounding. And now we're going to talk about using these exact values. Okay, now that we have them all down, we're going to do some examples with this. Okay, here's an example of a right triangle where it is a special right triangle. So because it's a special right triangle, it is going to be proportionate to the other special right triangle that we found. And so these trig ratios will be the same. And we have a 45, 90, and so we can assume that our other angle measurement is going to be 45 degrees because that's the only remaining angle measurement that could exist so that my angles add up to 180. And I have a 45, 45, 90 triangle, and so some of these relationships are going to be proportional to the special right triangles that we saw in our last video. Okay, so if I wanted to find x, let's set this 45-degree angle as my reference angle. Then I know that x is my opposite side, and I have the hypotenuse side. So I'm going to use sine of 45 degrees is equal to the opposite side over the hypotenuse side. And I'm going to solve this trig ratio by multiplying both sides by 4. And now normally when we get to here, we would type 4 times sine of 45 degrees into our calculator, but that would give us a decimal answer, and what we want is an exact value. So what I'm going to do is I'm going to use the exact value for 45 degrees. Sine's value at 45 degrees is the same thing as square root of 2 divided by 2, and I'm going to multiply this by 4. And that's going to give me my x value. When I'm multiplying fractions, I want to multiply numerator times numerator and denominator times denominator. So I will have 4 square root 2 over 2. And then I'm going to reduce this 4 divided by 2 can simplify to 2 root 2. So this is my value for x, and since it's a 45, 45, 90 triangle, rather than setting up another trig to find y value, I'm going to remember that in a 45, 45, 90 triangle that these two legs are going to be congruent. So not only is 2 square root 2 the value of x, it's also the value of y. Okay, for my next problem, I've got a 30-degree angle, a 90-degree angle, which means my remaining angle is going to be 60 degrees. I'm going to set 30 degrees as my reference, and I'm going to try to set up a trig ratio that will solve for x. Can you decide what trig ratio to use and write it out? Pause the video and give this a try. Okay, I have tangent of 30 degrees is equal to x over 7, where opposite side over the adjacent side of the 30-degree angle. To solve this, I'm going to multiply both sides by 7. And then I'm going to replace my exact trig value for tangent of 30 degrees of square root 3 over 3. And I'm multiplying this by 7. And my final answer will be 7 root 3 over 3 is the value of x. Last example that we'll do is another 30, 60, 90 triangle where I want to find the hypotenuse is u and the adjacent side of the 30 degrees is v. So I want the hypotenuse and the adjacent side. Okay, so I'm going to set up two separate trig ratios so that I can solve for u and v separately. Pause the video and see if you can set up the two trig ratios we will need to find u and then a trig ratio to find v. Okay, I used a sine of 30 degrees. Sine of 30 degrees is opposite over hypotenuse, and a tangent of 30 degrees is opposite over adjacent. So these are the two different trigs that I can use to solve for u and v. I'm going to solve u, and then I'll let you try v on your own. So the first thing I'm going to do is I'm going to notice that u is in the denominator. So I'm going to start by multiplying both sides by u. So I'll have u times sine of 30 degrees is equal to 2. And then I'm going to divide both sides by sine of 30 degrees. So u is equal to 2 divided by sine of 30 degrees. So sine of 30 degrees is an exact trig value that I can use. That exact trig value is 1/2. So u is equal to 2 divided by 1/2. And to divide by a fraction, it's the same thing as multiplying by the reciprocal of that fraction. So u is equal to 2 times the reciprocal of 1/2, which is 2 over 1. And I multiply my numerators and I'll get 4 over 1 or just 4. So my value of u is 4. See how far, pause the video and see how much of the tangent you can do on your own. Okay, I started by multiplying both sides by v, and then I divided by tangent of 30 degrees on both sides. I replaced tangent of 30 with its exact trig value of square root 3 over 3. Instead of dividing by a fraction, I multiplied by the reciprocal of that fraction. I multiplied my numerators and got 6, multiplied my denominators by square root 3, saw that I had a square root in the denominator, so I rationalized my denominator, which gave me 6 square root 3 over 3, and I reduced my 6/3 to be 2 square roots of 3. Okay, that's it for special right triangles and exact trig values.